Last meeting, we solved up to problem number 4 for centroids. So today, we'll continue on to problem number 5. Number 5, a beam has the cross-section shown in the figure. Compute the moment of area of the shaded portion about the horizontal centroidal axis x sub O. So this is your horizontal centroidal axis x sub O of the entire section. Note, in strength of materials, the result of this is used in computing for maximum shear stress. So we'll use this concept in our later topics. Okay, so let's begin. Again, moment of area about this axis. Now the problem is we don't know where that axis is located. So we have to solve. It's a centroidal axis, so basically we need to solve for the centroid. Now, this figure is symmetrical along the y-axis if you draw a straight line here, right? It has one line of symmetry. So meaning, one line of symmetry here. So meaning centroid, we know to be here at this point. So the only thing left to solve for is this y bar, or position of your horizontal axis. So considering this as our reference point, this is the location of our x bar, or x sub O to denote it's a centroidal axis. Okay, so let's begin. So concept is the same as before, or the steps are the same. First, divide your shape into recognizable shapes, or geometric shapes. So what I'm gonna do, divide it into 3 areas. So we have this rectangle, and this rectangle. So for now, we'll ignore this shaded region because the goal here is to find the centroidal axis. We'll notice this shaded region in computing for moment of area. Okay. So I'll call this my area 1. So let me just zoom in. So this will be my area 1. There. Okay. And then let's choose an area 2. Here. Okay. And then area 3. Okay. So there. Now you don't have to divide it this way. This is just for me the easiest way to divide it. You can say this is your area 1, this very long rectangle. Then the edges are area 2, 3, 4, 5. You can do that as well since they're all just rectangles. But again, my division is this way. So area 1, area 2, and then area 3. Next is to get the values of those areas. So let's start with area 1. Can anybody give me the area of area 1? Correct. Michelle and Jose. So Leong and Legado. Very good. Oops. Okay, 6. Why? Again, this is just a rectangle, so base times height. Base is given to be 6. Height is also given here, right? So that's 1. Therefore, this is 6. Next, area 2. Can anybody give me what area 2 is? Correct, it's 12. Correct, Nicolas and Lauren. Buena chua. So, again, base times height. This is just a rectangle. Base is this thickness. It's given to be 1. So 1. Height is also given 12. So therefore, this is 12. And what's area 3? Correct. Correct, Naomi and Lorraine. So Rivera Minoso. Okay. It's also 12. Again, base times height, since this is just another rectangle. Base is given 12. Height is this, which is 1. So this is also 12. And then getting the total area, that's just A1 plus A2 plus A3. What's the answer? Correct, Kurt and Naomi de la Cruz Minoso. Right. So 30. And then next, again, we already know the location of your X bar, right? It's here. Since this is symmetrical along this line. So the only thing we're looking for is Y bar, as you can see there. And then to solve for that, it's A Y bar equals summation of AY. We already know A, 30. So just copy that. And then let's start with A1. So A1, you're gonna use your choose a reference axis. In the drawing, the reference axis is already given. It's here at the base. So again, reference axis is the axis where you'll base your directions from or measurements from. So as you can see, Y bar is also measured from the base. That's why that is our reference axis. So now to get Y1, so this is your Y1. Let me just show you. So this is your area 1. Right? And then its centroid, you already know the centroid of rectangle is just half its span, so it's somewhere here. Right? Therefore, distance of that point or reference axis is your Y1. And then how do we get that? So let's look. So we have 1 here at the base, and then plus 12, we'll get 13. So 13 is up to this point. So the only thing left is to get this height. Okay? And that height is just half the height of your rectangle, right? Since this is 1 inch, the dimensions of these are 0.5 and 0.5. Therefore, distance of this point, your centroid, to the base, or reference axis, is again 1 plus 12 plus 0.5. And that is 13.5. So you can just write it so you'll understand how 13.5 came to be. So 1 plus 12 was 0.5. So that's A1. Next, let's do the same for A2. So A2, centroid is somewhere here, right? And then this is your Y sub 2. Again, distance from your reference axis. And then to get that, again, you're going to look at your measurements. We have 1 here. So we'll already have a 1. And then plus whatever this length is. Again, this is a rectangle. So the span or the measurement of this with regards to the shape itself is just half the height again. Total height is 12. And then half of that is 6. So this is 1 plus 6. So 1. And then this length is 6. Okay? And then finally, plus A3. Can anybody give me what's the distance of A3 from the base? Correct. Very good. Correct, Colin and Michelle. So very, yeah. 0.5. Hindi na po ba kasama yung 1 inch sa 6 inch? Where? What do you mean? Here, ito? Okay, and again, A 3.5 because this is the centroid. This is the centroid of your area 3. And then distance to the base, that's your y sub 3. And total height is 1, half of that is 0.5. So from this, please solve what's y bar. Correct. Y bar is you have to divide by area. So correct, Colin and Simon, Pochero, Pere. So 5.7. Okay, so this is not our answer. We're not looking for the centroid. We're actually looking for moment of area about that centroid. So now, I'll teach you how to do that. So moment of area about centroid. So let me just get this figure again. Okay. Let's put it. So now let's talk about what will happen. So, yeah, I'll remove this. Okay. All right. So moment of area, if you remember, that's just A times distance, right? So what's gonna happen here is this is the shaded portion that we're concerned with. So we're gonna take the area of your shaded region, take its centroid, and then multiply your area by the distance of your centroid from your centroidal axis. So again, we have an odd shape, so we can just get the centroid of your teeth. So we'll do the same with the earlier process wherein we divide it into recognizable shapes. Okay, so I'll do the same. We have another rectangle here, so I'll do that. Okay, and then there's another rectangle, so you can use that as well. So let's choose a different color for this area. And again, moment of area is summation of AB. Therefore, let's start with area 1. Okay, so let me just label each of that. Area 1, area 2. So area 1, we already know because it's the same shape as our previous figure. Area 1 is 6. So I'll just write that here. Area 1 is 6. 6 times 1, so 6. Now what about area 2? So area 2 is not the same as this one, right? Okay. Okay. It's different. Your height is different. This is the total area of the previous drawing. Now it's just this. So to get that, again, base times height. Base is the same. It's still 1. And then height is now this. So to get that, right? The reference is your y bar. So this length is just this total length, right? 13 minus whatever this is, which is 5.7. So 13, again, total length here from the base, minus y bar. What's the answer? Correct, 7.3. Correct, Matthew and Jose. So, tayo nilang nagabi. Kanilon. 7.3. Again, it's not 12 minus y bar because we still have a 1-inch height here. So 13 minus y bar is 7.3. Okay. Now, summation of AD. So that's A1 times this. Okay. So let's call that Y1 or distance 1. So to get that, again, we'll do the same as what we did earlier. It's this total height, right? So that's 12 plus 1 plus 1. So 14. And then minus this. And then minus whatever this is. Okay? So again, total height 14 minus y bar. And then we still have a distance or measurement above your centroid. So we have to subtract that as well. And that distance is 0.5, right? Because total height again is 1. Centroid is at half that position. So this is 0.5. So this is minus 0.5. Okay? Let's delete that. Next, let's move on to area 2. So plus area 2. And then for area 2, this is your distance. Sorry, not that. Distance from your centroidal axis. So D2. Once again, how do we get that? So, okay. First of all, this is not the centroid of this area. So centroid of this area, okay, is somewhere here. So this is not correct. So this is your D2. Okay. So now to get that, one way you can do is taking this length, right? Because we know this to be 13. So 12 plus 1, that's 13. Okay. Then subtract y bar, okay? And then now I need to get this. I need to subtract this, okay? To get D2. And this is just half whatever this total height is, right? Or we can, yes, we can write it as whatever this height is divided by 2, since these two are equal. So 13 minus y bar over 2. So correct, Ricky Colin. Very good. So again, 13 minus y bar over 2. 13 minus y bar is already this length. We want to know D2. And D2 is just half the total height. That's why over 2. Okay? Then now, Knowing A1, Y bar, and A2, please solve what's moment of area. Correct, Lauren and Marilyn. Palios is true. Okay, it's 73.45. Can anybody give me the unit? Correct, Marilyn? Anyone else? Yung wala pang point? It's not just inch. Kulang. This is an area multiplied by distance. So that, what does that make? Area is square inch. But this still multiplied by distance. Correct. Kung wala pang 2 points, correct. Michelle, but you already have 2 points. As well as Colin. So I'll give it to Matthew. Inch cube. Again, because it's area times distance, so inch squared times inch. It's inch cube. There. That is number 5. Any questions for number 5? Please answer in the chat. Okay, great. Let's have the last item for this topic. Number 6. Okay. So we have a line. We don't have an area anymore. So number 6, locate the centroid of the bent wire shown in the figure. The wire is homogeneous and of uniform cross section. So that just means we can consider this as a line. So same thing like we did earlier with our line example, separate this into recognizable segments. So let's have this. So we have this arc, right? Let's call that your area 1, line 1. And then we have this, right? This is your line 2. And then we have this. And then let's call that your line 3. Okay, so same thing, let's get the value of each line 1. So this is an arc. Now, if you remember from your math, the equation of an arc is just r theta. And our theta is 60 degrees. Our radius is this, which is 30. So you can just write that r theta 30 times 60. And take note, this goes for all of your subjects. Okay? Whenever you have an angle in degrees that is outside a trigo function, always convert it to radians. So if you're going to use r theta, so that's 30 times theta is 60. This is in degrees. We need to convert to radians, so times pi over 180. Okay, this is for every subject. Whenever you have an angle outside your trigo function, so outside sine, cosine, tangent, etc., always convert it to radians. But since we're doing things differently, we can use the equation given to us in our lecture. So we have an arc. This is your arc. So the equation for length is 2 alpha r. alpha being half the length of the subtending angle, or half the measure of your subtending angle. So let's write that out. Alpha. So the angle is the same for length 1 and length 2. So it's just alpha. And that's just theta over 2. Right? Half the measure. So this is 60. That's 30 degrees. And then following our equation, line 1, it's 2 alpha r. Alpha again is 30. This is in degrees, so convert to radians. So times pi over 180. And then radius 30. What's the answer in pi? In pi. Okay. Correct, Michelle. Correct, Gian and Kurt Bustos de la Cruz. It's 10 pi. I'm writing 10 pi just so I don't have to store the decimal in our calculator. Next, length 2 is easy. That's just 20. And then length 3, it's the same as your length 1, right? Same r, same angle. You can just copy. It's equal to L1. And that's 10 pi. Okay. And then next, solve for your capital L. Total length. So L1 plus L2. Plus L3. What's the answer? Correct, Michelle. Nicolas. Oh no. That's too rounded off. So correct, Alyssa and Rafaela. Pangalangan, kamay. $82.83. You round off properly. And then, as usual, if you have a decimal place or a value that's not a whole number, store in your calculator. And then, next step, use your summation of L bar, L distance bar equals, sorry, capital L, then either X bar or Y bar, summation of LX. Now again, X bar, or distances X, are the distance of your centroid from the Y axis. The reference Y axis is already given. And if you've noticed, this is symmetrical, right? Therefore, your centroid is somewhere here, somewhere along this line. So what is the value of X bar? Correct, Rafaela and Pamela. Pangalangan, tama. Zero. Very good. So again, this one good thing when you know how to recognize symmetry. So by symmetry, X bar equals 0. Now this only because your Y is directly on the line of symmetry. Now if your reference Y axis is somewhere here, okay, X bar is not 0. So this is still the centroid. This is your X bar. And that's just the total length divided by 2. Okay? So again, just because it's symmetrical, it doesn't always mean your X bar or Y bar is 0. Make sure to look for your reference axis. Okay? So just to make that clear. Right? And then now, since we know that, let's solve for Y bar. So L Y bar, summation of Ly. L Y bar. Okay, now let's start with L1. So for L1, Centroid of L1 is somewhere here. Okay. Considering the base as your reference x-axis, this is your y1. And how do we get that? So let's look again at what we have. So again, we have this arc. We have an equation for x bar. Okay, so even though this is x bar and we already know x bar is 0, doesn't mean we can't use that. Make sure to know what that measurement is. So this x bar is the distance from point O along the horizontal. So along your angle bisector. Angle bisector meaning the line that divides your angle into two equal parts. Okay, so this is an angle bisector. Therefore, in our drawing, this is the angle bisector, right? And then along that line, this is the distance of your centroid, which is r sine alpha over alpha. So this length, okay, so from here to here, this is r sine alpha over alpha, okay? And this is what I want to get. Like you've noticed, we have a right triangle, okay? And then this angle is your alpha. Okay. And then, so using trigo functions, this height of your right triangle is the distance of your centroid to your y-axis, to your x-axis. So that's your y1. So to get that, again, I'll just separate the solution here using sine. Okay. So sine alpha equals opposite y1 over hypotenuse r sine alpha over alpha. Therefore, y1 is r sine alpha over alpha times sine alpha. Okay, so that is what I'll write. So again, y1 is r, and r radius is 30. So 30 sine alpha, again, alpha is 30 degrees over alpha. Alpha again is 30 degrees. This is outside a trigo function. So I need to multiply this by pi over 180 to convert it to radians. And then times sine alpha. And again, alpha is 30. Yeah. That is your y1. Okay. Right? So now that that's settled, let's move on to y2. Length 2. So this is the centroid of your length 2. What is y sub 2? Again, y sub 2. Anyone else? Correct, Rafaela. But you already got 2 points. Correct, Simon. Cochero. Who else? Legado. 2 points ka na. Who else? Correct, Joaquin. Lustre. Charay. It's 0. Again, y is distance from the x-axis. Your line 2 is directly on the x-axis. This is the centroid, so there's no distance from the centroid to your x-axis. That's why it's 0. Okay? And then plus L3. So again, length 3 or line 3, the same as line 2. So if you try to solve, draw your angle bisector. Okay? And then your centroid is somewhere here. I draw a straight line here. This is the y sub 3. And again, this is alpha. So same thing. It's 30 sine alpha, which is 30 over alpha. Again, 30, convert to radians. And then sine alpha. And that is it. Please solve what's y bar. Correct, Kurt. Or 2 points ka na. Correct, Rafael. Correct, Zaira. 10.87. So therefore, final answer, 0. By the way, since we're given units here, you can include units in your answer. So 0 cm, cm. And then if we're looking for the coordinates of your centroid, it's 0 centimeters, 10.87 centimeters. Okay? There. And that is number 6. Any questions for number 6? Please answer in the chat. Okay. Now, in the case that your arc is not symmetrical along the x-axis, you already know how to get this length, right? We're going to use cosine instead of sine. So cosine alpha equals whatever this length is over hypotenuse, which is again r sine alpha over. Just keep that in mind. Now, obviously, if our arc is positioned this way, and then this is your alpha, this is your centroid, so this length is just r sine alpha over alpha. Okay, so keep in mind the orientation of your arc. Okay. Since you don't have any questions, that ends our topic for centroid.